Welcome back, everyone. Next up, we have Ideal Power. It trades on the NASDAQ under the symbol IPWR and is pioneering the development of its broadly patented bidirectional semiconductor power switch, creating highly efficient and eco-friendly energy control solutions for electric vehicle charging, renewable energy storage, UPS data center, solid-state circuit breaker, and other industrial and military applications. The company is focused on its patented bidirectional bipolar junction transistor semiconductor technology called B-TRAN. It's a unique double-sided bidirectional AC switch able to deliver substantial performance improvements over today's conventional power semiconductors. Let's welcome President, CEO, and Director Dan Brdar, as well as Tim Burns, the CFO. Welcome back, gentlemen. Nice to see you again.
Thank you for having us.
All right, the floor is yours. Call me back when you're ready for questions.
All right, thank you. It's a pleasure to actually give everybody an update on where Ideal Power is. This is an exciting year for us in terms of our progress towards developing and now commercializing our technology. What our technology is, it's a disruptive semiconductor device that's used for high power applications that has some really compelling advantages compared to the conventional technologies that have been in the marketplace for many, many years. B-TRAN is really a technology that can impact quite a few markets that have some large growth ahead of them. Things like electric vehicles, renewables coupled with energy storage. And we actually enable some new applications, things like solid-state circuit breakers, where conventional semiconductors have just not been good enough to actually make those applications viable. We introduced our first commercial product earlier this year, our SymCool power module, and we'll be beginning sales of that later in 2023. Our business model is asset light. We do not own a wafer fab. We are really leveraging the big investment that's been made by the semiconductor industry in processing silicon wafers so that we don't have to spend capital on doing things that are special to actually be able to make the product. We're now in the process where we're beginning to commercialize, so we're engaged with multiple target customers in our key market segments, and we'll talk some more about that. And we're in a good shape from a cash standpoint. It's certainly a difficult market environment out there in the small and micro cap world, but we have plenty of cash to take us through 2024. And we're really focusing on continuing to build that broad patent estate that we've got for the technology, which right now consists of 74 patents that have already issued and another 22 pending. Let's start with a little bit about what is B-TRAN. If you look at the picture on the right, it is a picture of a B-TRAN die. It's very small. It's about size of a dime. And if you were to flip it over, it looks exactly the same on the other side. It is a proprietary semiconductor device that is really unique in the fact that it is made by fabricating both sides of a wafer, which is really unusual in the semiconductor space. Typically, wafers are only fabricated on one side. And as a result of what we have figured out in terms of how to make it, we now have a device that is a unique architecture all its own. Just like IGBTs are an architecture and MOSFETs are an architecture, B-TRAN is an architecture. And it has the capabilities of being inherently bidirectional, where you can use one device to control the flow of energy in both directions. And it is more efficient. It has lower losses. And those lower losses translate into less thermal management, less complex thermal management, less heat that needs to be dissipated. Well, and that allows the OEMs that incorporate our product to have smaller, lower cost product designs. If you look at how bidirectional switching has historically been done, it uses pairs of IGBTs and diodes to control the flow or block the flow of energy in either direction. As batteries have become lower and lower in cost, they are becoming used more frequently in things like electric vehicles, coupling energy storage with solar, standalone energy storage for demand charge management. It's driving the need for better bidirectional switching. What has traditionally been done with 4 devices, B-TRAN can do in 1 device. And because of the actual architecture itself, if you look at the conduction losses of B-TRAN, compared to the conventional approach to making bidirectional switches, the conduction losses are more than 5 times better. And that translates into more usable kilowatt hours if it's a solar installation or energy storage, or greater range for the electric vehicle using the batteries in the vehicle. The market where we really play is today served by IGBTs. That's the current technology for high power applications. That market is expected to be about $11 billion by 2026. And interestingly, the two biggest segments of that market are already electric vehicles and renewables. And both of those are still really early in their growth stage. So they are really going to dominate the marketplace over the coming years for the semiconductor market. Other key markets where we're going to be applying our technology are things like UPS systems for data centers and motor drives, where we can help make those applications more efficient also. Taking just a quick look at electric vehicles, electric vehicles are really substantially different in terms of the amount of electronics that they have versus the conventional combustion vehicles. You typically used to see a couple hundred, several dozen semiconductors in a vehicle. Nowadays, with electric vehicles, there are literally thousands of them. They're used in the windshield wipers, the window motors. They're used in the drivetrain, the charging system for the batteries, used for changing the voltage on the vehicle for different applications. So a lot of semiconductors go into the vehicles these days. Ours in particular really focuses on the high power parts of that, things like the traction motor, the battery charger, and the DC to DC converter. One of the big challenges that electric vehicles have to get to mass adoption is their high cost. That, coupled with range anxiety, are two things that all the automakers are really focused on to get high volume, lower cost vehicles with more range to address those two consumer issues needs improvements in both battery technology and in semiconductor technology. Power switches really play an important role in things like the traction inverter and the onboard charger and for circuit protection. And what I don't think a lot of people realize is semiconductors are the largest cost component in an electric vehicle after the battery. So getting cheaper semiconductors that give better performance is a pretty substantial challenge. And that's really where B-TRAN comes in. By making bidirectional switches for things like regenerative braking and the drivetrain with B-TRAN, you can eliminate a lot of extra switches. You go from 4 switches to 1. But more importantly, you can do it more efficiently. So B-TRAN can be made in silicon, but still improve the range of the electric vehicle by 7 to 10%. So it helps both on the cost and the range anxiety. And then as materials like silicon carbide become lower cost and higher in quality, because B-TRAN is an architecture, in the longer term, we'll make a silicon carbide version of that device as well. Looking at a couple of the other markets that we're immediately going after, the first is renewable energy. Clearly has a large growth ahead of it, compound rate of 12% a year. The semiconductors for renewable energy are used in the power converters for the solar and the wind installations, and also when energy storage is coupled with them, you need bidirectionality to both charge and discharge the batteries from your renewable energy source. Another key market for us are data centers. There's UPS systems that sit at the very entrance of every data center where all the electricity has to come through the UPS. It results in conduction losses that can be pretty substantial in terms of the waste of electricity. And electricity is the largest operating cost for a data center. We did some work looking at what an improvement in semiconductor efficiency would do for a data center, and using B-TRANs in the UPS systems instead of the conventional marketplace would save the average data center about $2 million a year in electricity savings. So substantial improvement in their operating cost. One market that is actually not served very well by IGBTs today are solid-state circuit breakers. And this is where B-TRAN actually becomes an enabler. Traditional circuit breakers are electromechanical devices that act relatively slowly. They need to have maintenance on them. They arc, which is a potential safety hazard. But a solid-state circuit breaker really is something that the industry and the military have been looking for quite some time, because they can act orders of magnitude faster. They have no arcing. They don't have maintenance issues. So we work together with a company called Diversified Technologies, who has expertise in circuit breaker design, and proposed to the Navy a B-TRAN-based circuit breaker. And it's something that really is mission critical for the Navy under the ship electrification program. We actually were awarded the project. We have been focused on getting our products made and fabricated and delivered to DTI so that they can incorporate them in the breaker that they're going to build and test for the Navy. Excuse me. We've already completed our first volume shipments to DTI. We'll be wrapping those up later this month. But more importantly for us it really validates the technology, and it has driven a lot of interest from other companies that are very large players in the power market that are interested in solid-state circuit breakers for industrial and utility applications. So it's drawn quite a few companies to want to work with us so they can use B-TRAN for circuit breaker applications that in more conventional approaches, as well as what the military is looking for. Our focus this year has really been on commercialization. So we're really now engaged with customers, getting them to understand the technology, getting them involved in looking and testing it for themselves. We entered into a development agreement with one of the world's largest automakers earlier this year, where they're looking for a custom B-TRAN module that would be used in the drive platform for their electric vehicles. We are getting close to the end of phase one of that, and we'll be talking about what phase two looks like here in a little bit. We're also engaged with a whole variety of companies that are evaluating the technology now for their application. That includes another global top 10 automaker, in addition to the one that we're doing the custom module for, one of the largest providers to solar power conversion, to Ford's Global 500 power management companies. Those are the kinds of companies that make things like circuit breakers and protective relays and transformers that serve the industrial and utility space. We're engaged with one of the leading commercial EV manufacturers, and also now a global tier one automotive supplier, as the tier ones are also starting to look at what can they do to bring innovative technology to all the OEMs that are focusing on bringing their electric vehicle products to the marketplace. The key to watch out for here this year, because it's such a key year, we've got quite a few milestones that we've said that we're going to be publicly executing against, and a lot of those are happening here in the near term. The first one we already completed. It was launching our first commercial product. It's what we call the SymCool Power Module. It's a multi-die module that's really targeted for the solid-state circuit breaker market. The design of that is complete. First builds are in progress, and it'll be available for commercial sale a little bit later this year. But also in the near term, a couple of key milestones are completion of phase one of the program we're doing with the global automaker. It really is all about getting through the qualification of the technology and moving into phase two, where we start to participate with a packaging company to actually build and test that custom module. We hope to be able to make that announcement here by the end of Q2. We're wrapping up the last couple of deliverables here on phase one, and the program looks like it's going very well, and we're in good shape. The next key thing that we're going to be announcing here before the end of the quarter is we've been doing work with our technology at small development fabs using companies like Teledyne and others that have development wafer fabrication facilities. But we're now completing our first volume fabrication run at a production level fab. We want to make sure that we have qualified a high volume source for this, and that entity is also automotive certified, so that as we continue to engage with the automobile companies, we have both the capacity and the partner that can make product for us in high quality and high volume. The other key thing that we'll be wrapping up here this quarter is the delivery to our partner DTI under the Navy program, where they will have the devices they need to actually make and test the breaker. We're on good track to get that accomplished, and we'll be wrapping that up here shortly. And then looking beyond the current quarter, a couple of key things that will be coming up will be our second commercial product. We plan to introduce that in Q3. It's an intelligent power module that builds on the SymCool Power Module and adds an intelligent driver that's really well suited for applications like renewable energy, solar coupled with storage, and things that are more industrial kinds of applications. And then we'll be delivering samples to the customers that have already signed up for our test and evaluation program in the second half of this year. And that includes the additional automaker that we're engaged with and some of the other companies that are interested in exploring our technology for use in their OEM products. Just a quick look at our IP portfolio. We have 74 patents that have already issued. About half of those are outside of the United States, and they include coverage in places like China, Europe, Japan, South Korea, and India. Another 22 pending. The coverage of those is pretty broad. It covers the architecture itself. It covers control methodologies and techniques in terms of how the device can be operated, some things on manufacturing that we've learned, and some application-specific things as well. And then to make sure that we really protect our IP as much as possible, we've come through a couple-year process working with Teledyne and others, learning how to make a double-sided wafer with good quality and good feature alignment front to back. We treat that entire process as a trade secret. So even studying our patents, somebody wouldn't be able to go out and make this device. There's an enormous amount of learning that has gone into that process flow to actually be able to make the devices for commercial sale. Looking at just some of our recent news announcements, they've really been largely around commercialization, the customer engagements like the top tier automaker, the global tier one automotive supplier, several others that are coming into our test and evaluation program. From a balance sheet standpoint, we've got just under 6 million shares outstanding, about 1.9 million options and warrants. The warrants that are out there are all, in some cases, very deep in the money. Great cash balance. We have about 14.5 million as of March, end of March. That gives us plenty of runway to get through 2024. Just as a frame of reference, our cash use last year was about 6.8 million. So we're tracking very well to our plans in terms of how we were going to use the cash, and no debt on the balance sheet at all. So very clean balance sheet and well positioned to go execute against the milestones that we've laid out there. So at this point, I'd like to open it up to the audience for questions that anybody may have.
Great job, gentlemen. And all right, let's jump into some questions. So what announcements are planned in the current quarter?
Yeah, I think there's really three that people can look for. One will be the completion of phase one of our program with the top 10 global automaker and entry into phase two. I think they'll see an announcement around our qualification of a high volume production fab. So we have capacity to make product for our commercial customers. That fab will also be automotive certified, which is key. And then the third one will be completion of our deliveries under the Navy program, because that's really validation for a lot of the customers that are looking to do work with us on the solid state circuit breaker application.
And can you talk about other companies developing this bidirectional power switch? Who are your competitors?
Yeah, bidirectional switches have been around for a long time, but what we see is because battery costs have come down, there's a real desire to do better bidirectional switching. But the competitors that we see out there they're just basically repackaging existing technologies, packaging multiple IGBTs in one common package or multiple MOSFETs in one common package. We haven't seen a new bidirectional architecture that's out there. So what we do see are the large players in the marketplace, the Infineons and the onsemi's, looking to serve that market with repackaged devices using conventional technologies, or in some cases trying to do things with silicon carbide devices, which unfortunately are just very expensive today.
Well, they've been around the market for a while. Why have they not been previously developed and released into the market?
Yeah, I think the big driver is the fact that batteries have always solved a lot of issues in our infrastructure and in transportation, but battery costs have always been too high for it to be a really focused effort. And what's happened is battery costs have dropped dramatically over the last 5 years. So it's now starting to make things like electric vehicles practical. It's starting to make coupling energy storage with solar to make the solar firm and dispatchable power economically reliable. So it's really driving the need to get better, higher performing, lower cost bidirectional switches because of what's happened with the affordability and availability of higher quality batteries.
Well, this is one of my favorite questions. What problems do you solve? Talk about your performance and cost benefits and what can be expected for B-TRAN architecture.
Yeah, if you think about electric vehicles, I mean, the two biggest issues we go after there are helping the OEMs lower their vehicle cost while at the same time increasing the range that's available from the batteries that are on the car. So really big impact. I mean, if you can get a 7 to 10% increase in range and reduce your vehicle cost at the same time, it's a big step towards addressing one of the key set of customer issues that are out there that are delaying adoption. On things like renewable energy or energy storage, we help make those solutions more practical, more economical, because you get more useful kilowatt hours out of the same amount of solar panels and the same amount of batteries. So it enhances the economics of those applications, which will help get them out of the need for subsidies as they get more and more economic.
Dan, talk about what is preventing large companies from producing competitive architecture.
Well, the architecture we have is very well protected from an IP standpoint. And if you look at the semiconductor industry, there really aren't very many new architectures that come along. IGBTs have been out for decades. MOSFETs have been out for decades. B-TRAN is the first new architecture that you see in the semiconductor space, especially in the silicon world, for a long time. So part of it is just inventing a new architecture is very difficult. It takes a lot of creativity, a lot of innovation, and it gives us an opportunity to really do something that is truly unique and differentiated in the space.
Daryl has a question concerning B-TRAN with a less energy burn. Has there been a study on energy or more specific electricity savings?
Yeah, we have. For example, we gave the example of a data center where we looked at if you took a UPS system and used B-TRAN in place of IGBTs, the typical data center would save $2 million a year in operating costs. We've done some other look at other applications. Like I mentioned, electric vehicles could get 7 to 10% more range out of the vehicle. It varies application by application, but the impact looks to be pretty substantial based on the analysis that we've done and the things that we've done working with some of our partners in the space.
Cliff wants to know if there are any grants you can get by manufacturing this in the U.S.
Yeah, great question. The CHIPS Act hasn't turned into actual programs yet, but we are working closely with our partners to see if we can help to influence some of that to actually get B-TRAN to be a recipient, or our partner, our fabrication partner, a recipient of some of the grant dollars that are going to come out of the CHIPS Act. In the meantime, we do see other grant opportunities with the Department of Energy and the Department of Defense that are more application specific. And we think there's also going to be opportunity over the longer term as we start to think about making a silicon carbide version of B-TRAN as silicon carbide quality and cost improves.
A question from David Schneider concerning the Form 4s for you and Tim that were just filed. Were those open market buys?
Yes, they were. We think that we are in a great position in terms of the company or our execution. It's a difficult time in the microcap space. So we thought the right thing to do was, since we just had an earnings call and got all our news out there, for the management team to go out and just do some open market buys.
And Lila Houston asks, with EVs, renewable energy, and your data centers, where do you see the initial sales coming from and most significant growth over the next 12 to 24 months?
Well, the near-term growth is going to be in the solid-state circuit breaker market. The design cycles there are shorter. It's what our first product is oriented around. Right behind that will be things in the renewables and energy storage space. And then the large volume opportunity is electric vehicles, but the automotive design cycle is longer. The objective under the program that we're doing right now with the global automaker is a production-ready product by 2025. So what you'll see is industrial applications like circuit breakers that'll start to drive revenue in 2024. Late 2024, starting to see renewable energy applications coming into the revenue stream, and then eventually seeing the automobile folks coming in for the EV platforms.
Will Salazar asks, are the companies that make your competing yet inferior products traditional semiconductor companies like Micron, NXP, AMD, etc.?
They are, some of those are. You would see companies like Semicron, onsemi, and Infineon. They're really the ones that are probably the large players in the high power space. And one thing to keep in mind is, as we think about working with automobile companies, they drive huge volume in the long term, and they're going to want alternate sources of supply. So our approach really is we're certainly going to be feeding the marketplace with product, but over the long term, our objective would be to license our technology to other large players in the space that have production capacity, who've already invested in the front end of the business for sales and service support, so that we can stay focused on technology and not be spending capital replicating what's already out there for distribution and service to customers.
Makes sense. Teresa Warner wants you to talk about your sales team and where are the customers coming from?
Interesting that we hired somebody that came from a silicon carbide company who's leading our sales effort, Jeff Knapp. He's got great relationships in the automobile space. We also added Drew Freeman to our board of directors, who was the head of automotive sales for NXP for many, many years, who's been a great door opener for us as well. A lot of the work that we've been doing over the last 6 months to a year has been well, getting the awareness out. But now what we're starting to see, our customers are finding us. We're getting inbounds on a regular basis now of customers that want to learn about the technology, who want to get samples and be part of our test and evaluation program. So it's a mix of us doing direct outreach to the network that we have and our members of our team have, and then the inbound that we're starting to see now that the technology is becoming more widely known.
Teresa also wants you to talk about any sales to date, and do you have any pre-orders?
It's early for that yet. As we bring out the first product later this year, we'll start to see that. There's a sales cycle that's involved that ultimately starts with getting devices in people's hands, which we're going to be doing here shortly. But because things like the solid-state circuit breaker application are less complex in terms of the standards and requirements versus the automobile industry, those cycles should be relatively short in terms of their evaluation.
Chester Munoz asks, what is your accounts payable schedule like? Is there a direct deposit on order or balance on delivery?
Yeah, so right now, we're in the process of commercializing the technology, so we haven't sold our first SymCool product. That's expected later here this year. But we would expect pretty standard terms, likely net 30 with our customers.
And Adam Herrera asks, after the sale, is there any recurring revenue?
Not likely, since it's really a product sale, but we're at such an early stage. There's so much new sales to be tackled that what will come later on will likely result in some opportunities for upgrades of the technology as we improve our drivers, as we enhance the technology and get things that are more plug and play replaceable that will capture some improvements.
Yeah, and in advance of those product sales, there will be some modest development revenue for that custom program. From module development with the top 10 global automaker.
Okay. Heath says, semiconductor technology is always advancing. How long can you stay competitive with your current model before you need to release more powerful or technological versions? And are you capitalized well enough for more R&D to address this?
Yeah, it's a good question. If you look at, for example, applications that are really heavily oriented towards conduction losses, for example, if we're 5 times better than the conventional approach for a bidirectional switch, that's a big gap to make up. Improvements in semiconductors tend to be slow because it's a materials-driven business that's driven by the device physics. And our roadmap has us going eventually to silicon carbide. So we have a long-term roadmap that will take the architecture well into the future, leveraging the continued investments that are made in this space in terms of materials improvements and fabrication improvements. So we think we've got a great roadmap to continue to just keep that technological advantage going over many years.
And Jack Silva wants you to talk about your raw materials. How do you acquire them and the costs associated with them? Plus, how have they been affected with the increase of inflation? Is there an issue with availability?
Fortunately, no. Since we're using standard silicon wafers, their availability has been good. We haven't run into any of the issues that we've seen with some of the other materials that are out there for semiconductors. We've been buying them ourselves to our specification, but as we move to the volume fabs, we will actually give the wafer fabricator our specification, and they will actually buy them. Because they're a large volume facility, they will actually have better buying power than we will. So they can couple our need with other wafers they're ordering from suppliers.
And David Schneider asks, as the automotive OEM goes from phase 1 to 2, have you been cleared to announce who it is yet?
Not yet. We're going to make the argument that we need to be able to name them because we consider it material. I'm sure they'll push back on that because I think what we're seeing is customers want to get as far as they can before competitors know what they're doing. But we're certainly going to make the argument and hope that we can start to name some of these folks.
Okay. And Don Slowinski, can you clarify his assumption that if you get designed into an EV platform, that essentially would be like a recurring revenue stream because you would be in each new model in the future? Is that a correct assumption?
Yeah, what we are seeing is the OEMs don't want to have multiple versions of their EV platforms. They want to have a base that they can build off of and use that for a variety of models of cars because they just don't have the ability to actually do all these different designs, maintain them all. So once you get designed in, they're going to be looking at how many vehicles can they apply that platform to. So our objective would be, get that first win, and it really starts to multiply the opportunity for us.
Wonderful. Well, we are out of time. Do you gentlemen have any closing remarks for us?
Just want to thank everybody for joining us today and asking some really great questions. It's always nice hearing an audience that really is knowledgeable about the space and uses our time really well. So thank you very much.
Wonderful. Thank you so much. Great presentation. And we would love to have you back with some updates.
All right. Thank you.
Okay. Thank you, gentlemen. Stay with us, everyone. We'll be right back with our next.